Welcome to How to Equation Solving. In this video, you will learn how to solve a variety of different equations, including a one-step equation by all of the different operations, adding, subtracting, multiplying, and dividing. Some one-step equations that are a little more complicated, like using the reciprocal and when it's the number minus x. Two-step equations, multi-step equations, equations with variables on both sides, and then just some trickier equations in general. So if you're not interested in every slide, you might want to use the content guide to direct yourself to the slide that you need. When you get to each slide, press play to hear how to solve that type of equation. In this equation, we're trying to solve a basic one-step equation where x is being added by a number. So we're going to solve by subtracting. Anytime you're solving an equation, your objective is always to isolate x, so you're trying to figure out how to get x by itself. So in this case, I want to cancel out a 7. It's being added, so the easiest thing to do is to subtract. The golden rule of equations is that whatever you do to one side, you have to do to the other side of the equal sign. So if you can envision a line drawn right down the middle here, if you do something on one side of that line, you have to do something on the other side as well. So I have minus 7. The reason that works is 7 minus 7 is 0. So really I have x plus 0 now, because that's 7 minus 7, which means really all I have is x. I bring down my equal sign. Negative 12 minus 7. You can either enter that into a calculator, or sometimes it's easier to write it horizontally. So this says negative 12 minus 7. This also says negative 12 minus 7. I would change it to plus negative, and I would get x equals negative 19 for my solution. To check your answer, you actually go back to where the original x was and you change it to the number that you're now hoping it is, which in this case is negative 19. So I have x plus 7 equals negative 12, and I'm hoping that negative 19 plus 7 would equal negative 12, which it does. Negative 19 plus 7 is negative 12. So I know that I have the right answer of negative 19. So another one-step equation, we're trying to isolate x by getting rid of the minus 12. So since it's subtraction, typically what you would do is the inverse, which in this case is going to be to add 12. And if you do it on the left, you have to do it on the right. Now the reason this works is because since it's minus 12, that's really like having a negative 12. Negative 12 plus 12 would be 0. So x has been isolated. And then negative 6 plus 12 is 6. And so to check that answer, you would plug it back in. So you'd go 6 minus 12, and you're hoping that equals negative 6. Change it to plus negative, and it does. So the fact that when you plug it in it works means that you definitely have the right answer. Here's an example where you're trying to isolate x, and this time x is being bothered by the number 4. So since it's being multiplied, you would divide by 4. If you do it on the left, you have to do it on the right. That equal sign comes straight down. 36 divided by 4 would give you 9. Now over here, when you divide by 4, the reason this would isolate x is because 4 divided by 4 really cancels out and becomes a 1. And then 1 times x is just x. So x has been isolated. And then if you go back and check by doing 4 times 9, because that's what would go in the place of x, you'd get 36. So in this example, the number that has to be moved away from the x is the 9, and in this case, since it's a fraction, that means that 9 is dividing x. So to get rid of the 9, we're going to multiply. But I'm actually going to show the multiplication on the side instead of below. And I'll bring down my equal sign, and I know that 9 times 5 is 45. Now on the left-hand side, the reason this is going to isolate x is because you can put 9 over 1. And remember, when you multiply fractions, you're allowed to cross-cancel. So that 9 and that 9 would actually cancel out, making 1s, which means x has been isolated. X equals 45. So if you put 45 in here, 45 divided by 9 is 5. We know you have the right answer. Here's another one-step equation, and in this case, x is being multiplied by 3/4. So typically, you would choose the inverse operation to isolate x. So since x is being multiplied by 3/4, you could divide both sides by 3/4. I'm not actually going to do that, but I just want to show you what that would look like. That would mean I'm going to do 12 divided by 3/4. But now if I think about how do you divide fractions, to divide fractions you change the division to multiplication, and you change the second fraction to its reciprocal, so eventually it's going to become multiplying by 4/3. So instead of thinking it as dividing, I'm actually going to multiply by the reciprocal to begin with. So if I multiply by 4/3 on the left and multiply by 4/3 on the right, I should be good. I bring down my equal sign. 12 over 1. This 3 can go into 12 evenly, so 3 becomes a 1, 12 becomes a 4, and I end up with 16. Now the reason this works is because this 4 and this 4 would cancel, becoming a 1. This 3 and this 3 would cancel, becoming a 1. X is isolated. To check this answer, you would take the original problem, which is 3/4 x equals 12. You'd replace x with what you're hoping it is, which is 16 is the answer we got. So you'd put 16 over 1. 4 can go into 16 4 times. Multiply across, you get 12 equals 12. So x equals 16 is definitely the answer. This example is a little different because in this case you have 7 minus x. So the number that needs to be moved is 7. Since it's subtraction, a lot of people think that you would add, but let's see what would happen if you would add. So if I added 7 here, that would also mean I would add 7 here. And remember, your objective is to isolate x. 7 plus 7 is 14. So if I brought down my equal sign and rewrote the new problem, I would have 14 minus x equals 21. So x isn't isolated. It started with 7 and now it has a 14. So that doesn't work. So I'm going to get rid of that. Another thing to think about is if x was 21, 7 minus 21, if I put that over here, I would make that plus negative 21. The 21 is bigger and it's negative, so that would have come out to negative 14 and not positive 14, which is the number I wanted. So I know that that's not right. So let's try this again. I'm trying to get rid of 7, so the way I would get rid of 7 is I would subtract it, because 7 minus 7 is 0. So that's going to be the operation that's going to work. Since I did it on the left, I need to do it on the right. I bring my equal sign straight down. 14 minus 7 is 7. Now on this side, by minusing 7, I canceled 7. But notice that this negative sign in front didn't get canceled out, and it belongs to the x. So when I bring down the x, I'm also going to bring down that negative sign. So at this point, I figured out what negative x equals. I know that negative x equals positive 7. But I'm not interested in what negative x equals. I want to know what positive x equals. So same idea, just like up here, if you minus 7 on one side, minus 7 on the other, I changed this from a negative to a positive, so that just means I have to change the sign over here. So if I make this a different sign, make this a different sign. It was positive, it's going to be negative. So x equals negative 7. My original problem was 7 minus x equaled 14. So this time 7 minus, and now in the place of x right here, I'm going to put negative 7. And it should equal 14. Well, minus and negative is plus positive. 7 plus 7 is 14. On this problem, we run into a different situation where there are two items that are bothering x. So you have the 2 that's multiplying and the 5 that's adding. So at some point, we're going to have to divide by 2. And at some point, we're going to have to subtract 5. And the question is, which one do you do first? So we're going to do this in reverse PEMDAS. We're going to go in the opposite order that you would do it if you knew x. Normally you would multiply and then add, but since we're solving, we're going to go reverse. So we're going to get rid of the addition first. And to get rid of the 5, we're going to minus. Minus 5 from both sides. Bring down my equal sign. 11 minus 5 is 6. Bring down my 2x. I still have to continue to isolate x. 2 is bothering it. I divide by 2. X equals 3. And again, you could check this by taking your 3, plugging it back in. 2 times 3 is 6. 6 plus 5 is 11. I know I have the right answer. Here's a two-step example where x is being divided by 2 and subtracted by 6. So inverse operations, at some point I'm going to have to multiply, and at some point I'm going to have to add. The question is, which one do you get rid of first? Since you're solving the equation, you go in reverse PEMDAS. So we're going to get rid of the subtraction first. So to get rid of a minus 6, I would add 6. And if you do it on one side, you have to do it on the other. Equal sign comes straight down. Negative 8 plus 6 would be negative 2. And the x over 2 comes straight down. Still have to get rid of this 2 that's dividing x. So to get rid of it, I would multiply. So multiply both sides by 2. X equals -4. You would check your answer by replacing this x with -4. -4 divided by 2 would be -2 minus 6. I could make it plus negative is -8. I know I have the right answer. Here's an example where we're going to have more than 2 steps. So before you actually want to start bringing things from one side to the other, you want to actually make sure that you have done all the math that you can do. So if you just look at this expression right here, which has 3 terms, the 8x, the minus 3x, and the minus 10, you're just looking to see, can you combine anything? And since 8x and 3x are like terms, we can combine them to get 5x. I don't have to show any work to do that. I'm just doing it in my head that they combine to get 5x. Now I can isolate x using reverse PEMDAS. So you're going to add 10, which gets you 5x equals 30. Divide by 5, x equals 6. If you wanted to check it, I would go back to the original. So here, 8 times 6 would be 48, minus 3 times 6 would be 18, minus 10. 48 minus 18 is 30, 30 minus 10 is 20, 6 is the right answer. In this example, we're going to have more than 2 steps. Before we bring numbers from this side to the other to start to isolate x, we want to make sure we can do all the math that can be done. So if you look at this example, the first thing that can be done is distributive property. So 2x plus 8 equals 22. Now we isolate x using reverse PEMDAS. Minus 8 from both sides first. 2x equals 14. Divide both sides by 2. X equals 7. If you want to check, you'd replace your x with 7 and follow order of operations. So first parentheses, 7 plus 4 is 11. 11 times 2 is 22. 7 is the right answer. On this example, we're going to have several steps because first we can actually distribute and then second we combine. And we want to do both of those things, distribute and combine, before we bring anything over. Before I actually distribute, I'm actually going to go through and change any minus signs that I see to plus negative, which will be really helpful to ensure that I don't make any sign errors. Now I can see distributive properties happening here, but since I've changed it, the number that's being distributed is -2. So this 4x that's out front, I'm just going to drop that down because I haven't used that yet. I'm going to bring down a plus sign. So right here I changed it to plus, so I'm going to bring down a plus. Now I'm distributing. -2 times x is -2x. I have a plus sign inside the parentheses now. -2 times -3 is +6, and I bring down my equals 8. Now I'm going to combine my like terms. 4x plus -2x is 2x. I bring down my +6, and now I isolate. Now I'm ready to isolate. Now that I've done everything that I can do, distribute and combine, now I'm ready to isolate x by using reverse PEMDAS. So to do that, I would minus 6 from both sides, get 2x equals 2, divide both sides by 2, x equals 1. So in this example, we have variables on both sides of the equation. So on the left side, if you kind of draw a line down the middle, on the left side you have 4x minus 9. You can't do anything there because they're not like terms, so you can't combine. On the right-hand side, you have 2x plus 3. You can't do anything there because they're not like terms, you can't combine. So the first thing you want to do is figure out a way to get this 2x with this 4x. They're not separated by addition, they're separated by equals. So I can move this 2x over as long as I cancel it out on one side. My only options are addition or subtraction. So if I minus 2x right here, 2x minus 2x is 0. So that cancels out. Again, if you do it on one side, you got to do it on the other. So because I did it on the right, I'm going to do it on the left. So I'm going to minus 2x over here. My equal sign is always going to come straight down. That's a huge thing. 4x minus 2x would give me 2x. Bring down the minus 9. And on this side, I'm left with 3 because I canceled out my 2x. Now I'm ready to isolate x. So to do that, I would add 9. 2x equals 12. And then divide by 2. X equals 6. So in this example, before you actually start moving things from one side to the other, you want to distribute. So on this side, I'm going to distribute 6 and get 12x plus 18. And on this side, I'm going to distribute 4, and I'm going to get 12x minus 16. So I'm done distributing, I'm done combining, I'm ready to take one of my 12x's and move it to the other side. So I'm going to subtract 12x over here, because 12x minus 12x is 0, and because I did it on the right, I have to do it on the left. Equal sign always comes straight down. 12x minus 12x, that's 0, it's gone. So all I'm left with over here is 18. 12x minus 12x, that's 0, it's gone. I'm left with negative 16. And just be careful that that negative sign that's in front of 16, that's attached to the 16. So here I have this funky thing. I have 18 equals negative 16, which is not true. They're not equal numbers. If you remember from the problem before, when x equaled 2, that's saying that x was allowed to equal 2. This doesn't say, that x equals 18, because if it did, it would look like this. It doesn't say that. It doesn't say that x equals negative 16, otherwise it would look like that. It doesn't say that. It says 18 equals negative 16, which is not true. So what that means about x is that there is no solution. That's your answer. And what that means is no matter what you pick for x, if you pick the number 1, you'd have 12 times 1, which is 12, plus 18, that would be 30. 12 times 1, which is 12, minus 16 is negative 4. No matter what you pick, you're never going to get this to work. So there's no solution. There's nothing that will work for x. What's important on this problem is that this is your answer, no solution. This just helps you decide. Because this isn't true, that should tell you to put no solution. Here's an example where we're going to distribute first. So we get 18x minus 12 equals 18x minus 12. Now I'm ready to move one of my 18x terms over, so I'm going to subtract 18x from both sides. If I do that and bring my equal sign straight down, this 18x cancels, I'm left with negative 12. This 18x cancels, I'm left with negative 12. In this problem, I have two numbers that are actually equal to each other. Now this does not say that x equals negative 12. It just says that negative 12 equals negative 12. Since that is a true statement, what that means about x is that x can be all real numbers. No matter what you pick, you could pick any number that exists and replace it with x, and it would work out. And you can actually kind of see that here because you have the exact same thing on both sides. So on both sides, x is being first multiplied by 18 and then minus 12. So no matter what you pick, it will always work. This is the answer that you would put. This true statement helps you decide what to put. So here's an example where we're going to distribute first. 20x minus 10 equals 4x minus 10. So now that I've distributed, I'm ready to get my variables together, so I would minus 4x from both sides. Be careful on this step when it's time to move items from left to right or right to left. Choose to do the variables first. It will just be easier for you in the long run. So I have 16x minus 10 equals negative 10. I'm going to continue to isolate x by going in reverse PEMDAS. 16x equals negative 10 plus 10 is 0. I still have not yet successfully isolated x. It's still being bothered by 16, and it's multiplying, so I'm going to divide. X equals 0 divided by 16 is 0. And if you come back up here, if you put in 0, 4 times 0 is 0. 0 minus 2 is negative 2. 5 times negative 2 is negative 10. 8 times 0 is 0. Minus 20 would be negative 20. Half of negative 20 would be negative 10. 0 is a number that works. So there is a solution. It's 0. This is a basic two-step isolating x. However, the answer will come out to a fraction, so I just want to talk more about that. So first we're going to add 7 to both sides because we're going in reverse PEMDAS. So you end up with 3x equals negative 2. That's negative 9 plus 7. And then divide by 3. Be careful not to type that into a calculator because you would get a decimal. Your answer is negative 2/3. You cannot use 0.6 repeating. The reason for that is if you wanted to try to check that, you would never stop writing 0.66666 here because it's going to go on forever. So you would actually never be able to check that because you would never stop writing what x equals. Some people round it to 0.67. The problem is this number right here is a good approximation of this. It's not exact. So we want to get rid of that and want to be very clear that on this type of a problem, your answer should always be a fraction. Fractions are okay as long as they are simplified, which this one is.